Today we're going to do more problems involving U substitution, but we're going to focus in on problems that involve these three formulas you see here in red. Now, a word of caution about this formula right here, my open math will accept an answer like ln x plus c, but I won't. Unless you absolutely know x is positive, you need that absolute value sign there. And if you're curious about that absolute value sign, I've got it explained on the last page. So now let's jump down and start some examples. This first example doesn't require any work. To write down an antiderivative, we just use the Bible. This is 1/2 e to the 2x plus 3 ln of the absolute value of x. And that's all between 1 and 5. Now, if I went a little bit fast for you on that 3 ln absolute value of x, think of 3 over x as 3 times 1 over x. The 3 is a constant. It can come out, and the integral of 1 over x is ln of the absolute value of x. Okay, back over here, now we can evaluate between our two limits. This is 1/2 e to the 10 plus 3 ln 5. Now you can leave the absolute value off because 5 is positive, minus parentheses 1/2 e squared plus 3 ln 1. But ln 1 is 0, so our final answer is 1/2 e to the 10 plus 3 ln 5 minus 1/2 e squared. Okay, and that's it. Now we'll do some more interesting problems. For this next one, we're going to use the formula you see on the right there in red. So we're going to start with the U substitution. U is cos x, du is negative sine x dx. But I have positive sine x dx, so I'm going to multiply both sides of du by -1. Now I'm ready to do my replacement. I'm going to bring my constant out front, that's the negative sign. My du goes here, and then what's left is a 5 to the u. And now we're ready to use the formula in the red box. We don't use that a whole lot, but sometimes you need it. So negative 1 over ln 5 times 5 to the u plus c. But we want to leave our answer in terms of x's. So negative 1 over ln 5 to the cos x plus c. And there's our antiderivative. Okay, the next two involve definite integrals and rewriting using new limits. So for part A, the first thing we want to do is a U substitution. I'm going to let U be natural log ln x, and then du is 1 over x dx. Perfect. I have a 1 over x dx, so I don't even need to modify du. So my new integral will be u cubed du, and then let's find those new limits. To find the new limits, you evaluate u at the old limits. My old limits are 1 and e to the 1/2. So my new limits, to get the new lower limit, I take natural log of 1, ln of 1, and that's 0. And then the upper limit is ln of e to the 1/2, which is 1/2. So I'm going to go from 0 to 1/2. And that's the answer to part A. Just to rewrite as a u integral, that's an integral with new limits. So for part B, we want to evaluate that. So 1/4 u to the 4th between 0 and 1/2 is equal to 1/4 times 1/2 to the 4th minus 0, which is 1 over 64. Notice I never went back to x's. I changed my limits and I never went back to x's. Okay, one more just like that. Here again, I'm going to let u equal ln, well, this time ln 2x. Du will be 1 over x dx. Make sure you pause and understand that. And so our new integral will be integral of 3 over u du, and that takes care of both the 1 over x dx and the ln 2x. And then my new limits are, we don't have to draw a box for our lower limit. We want ln of 2, and then use the lower x limit, e over 2. That's ln of e, which is 1. So that's my new lower limit. And my new upper limit is ln 2 times e squared over 2, which is ln of e squared, which is 2. So that's the answer to part A. I'll give that an A. B will be to evaluate. Okay, so this is equal to, 3 is a constant again, so 3 ln absolute u between 1 and 2, which is 3 ln 2 minus ln 1. But again, ln of 1 is 0, so our final answer is 3 ln 2. All right, and that's it.